welcome to Berkeley Math Tournament channel. This is the first video of our series of walkthrough videos. The main goal of this series is to get you better prepared for the tournament and also give you a new perspective from our problem writer side to see how we actually put our ideas together and how we actually make our problems. My name is Wen. I'm the head problem writer of Berkeley Math Tournament this year and also the co-relay test organizer on BMT 2024. I made this set and now I'm going to solve this set with you all together. First of all, let's get ourselves familiar with the structure of this set. We see that there are mainly two different relationships happening here. The first relationship comes from these two blue arrows. We can call these as co-cyclic. What that means is that the answer to question 19 is actually the condition to question 20 and vice versa. So we call this the co-cyclic structure. And you will also see this structure from the set 5 in BmMT 2024 relay set. And what's added to that is these two arrows. And these two arrows, we call them as self-cyclic. What that means is that the condition to this problem is also the answer to that problem. Or more like one of the conditions to this problem will point you to the answer to this problem. What that means is, let's say we have an easier example as let x be the answer to this problem, compute the value of 2x. What we see is that x is the answer to this problem, and 2x is what we are asking for. So what that means is these two are both the answer to this problem. We can set up an equation there as x equals to 2x. And we can just solve for x as x will be equal to 0. So that's how we can solve a simple self-cyclic problem. And now we are familiar with ourselves, the structure of the set. And then interesting here is actually, if we look at the shape there and also the shape here, the relationship between question 19 and question 20, we see that they're exactly the same. And this is also the motivation behind we making this entire relay set. We will see that we have 7 sets. And if we combine the shapes of the entire 7 sets, they are going to be becoming the shape of BmMT. So that's why we want to make this set look like this, and this is also the motivation behind how we want to make our problems. And this is also from the problem writer perspective, where we want to have the geometry into our relay sets. So now let's actually get started with solving these two problems. So I saw that problem 19 is a little bit long, but problem 20 seems a little bit easier to read. How about we start with problem 20 and see how we can go from there. So in question 20, what we basically have is we have 3 expressions and exactly 2 of them are equal to each other. But at this point, since we don't know any relationships between N19 and N20, which means that it's hard for us to determine which 2 are exactly equal to each other, and that's why maybe we have to look back at question 19 to see how that will help us to determine which 2 expressions are equal to each other in problem 20. So now let's look at our question 19. In question 19, what we have is we have 3 parallel lines together. Let's draw them out as this. Alright. And then what we have is our first line is L1, our second line is L2, and our third line is L3. And we also have the fact that A lies on L1, B lies on L2, and C lies on L3. An interesting thing here is AB is equal to N19, and we are trying to compute AC. If we're trying to compute AC, what that means is we're asking for the number or the value of AC. So AC should also be the answer to question 19. So AC should be also equal to N19, but we also have that AB is equal to N19. So we set up an equation or a relationship between AC and AB, which means that AC is equal to AB. This is how we utilize the relay structure, or more specifically this arrow, to help us in making that into a condition of our problem. I think this is the coolest part of this problem. And let's continue with this. So what we have is we have AC equals to AB. That shows that this triangle is an isosceles triangle. And we also have that BC is equal to N20 times the square root of 10. So let's see how we can go from there. So we have A there, and we also have B on this line, and we also have C on this line. But it's very hard for us to determine now on like the relationship between these 3 different angles in a triangle. So it's possible that we can have an isosceles triangle as BAC, where A is an acute angle. It's also possible that our angle of A can be a right angle, or it can also be greater than 90 degrees. Let's think about those two cases afterwards, but let's focus on the acute case first. And what we'll see is that we have BC equals to N20 times the square root of 10. Since it's a little bit hard for us to express N20, or N20 is something that we are more unfamiliar with. How about let's just write N20 as x. So we will have N20 equals to x. So we will have x times the square root of 10 as the value of BC. Or maybe it's better for us to write it as square root of 10x. I think this is more easier to understand. Okay, so we will have the value of BC as square root of 10x. And what we will also have is we'll have AB equals to 19, and 19 and AC equals to N19, which means that these two lines are equal to each other. And we'll also know that the distance between L1 and L2 and L2 to L3 are N20. So if we drop the altitude from B to both L1 and B to L3, and maybe label these points as D and E, we will say that BD will be equal to PE as x. So what we see is this is a right triangle here as triangle BDC. And by the Pythagorean theorem, square root of 10x is our hypotenuse, and we can derive DC with the value of square root of 10x squared minus x squared, and take a square root of that. This will give us 3x. So this will tell us that DC is equal to 3x. Alright, cool. And what we can do next is how about let's also drop the altitude from A to line 3. What we will get next, let's label this point as F. Okay, so we have these two lines x apart and these two lines also x apart. This tells us that the distance between A to F is 2x. What else can we know? Okay, seems that these are the limited informations we have right now. How about let's also label C, the distance between C to F, as y. And what we have next is DC plus CF will be equal to 3x plus y. And we will also have DF equals to AE. So we will also have AE as 3x plus y. And another interesting thing here is, or another condition we haven't fully utilized, is that AB is equal to AC. So by Pythagorean theorem, what we can have is AB is the hypotenuse of this right triangle, and AC is the hypotenuse of this right triangle. So let's set up the equation of AB squared as x squared plus 3x plus y squared. And we also know that this is equal to AC squared. And AC squared is equal to y squared plus 2x squared. So let's try to solve this. We'll try to see what condition or what relationship we can see between x and y. So what we have here is we will have x squared plus 9x squared plus y squared plus 6xy is equal to y squared plus 4x squared. And what we can do next is we can cancel out y squared on both ends. And what we have is, so this side we have 10x squared, this side we have 4x squared. So 10x squared minus 4x squared will give us 6x squared. And 6x squared plus 6xy is going to be equal to 0. And then the interesting thing here is we know that x is referring to a distance between two lines, and y is also referring to a distance between 2 points. What that means is x and y should both be positive. And if x is positive, xy is also positive, then both these two terms will be positive. And the left-hand side should be greater than 0. However, our right-hand side is equal to 0, which means that this equation cannot happen. So this case of angle BAC as an acute angle is not true. So we can look at the other two cases here, where we will have angle BAC greater than 90 degrees or angle BAC equal to 90 degrees. However, one interesting thing is that if we drop the altitude from B to L1 and to L3, and also drop the altitude from C to L1, then the shape of the things we can form here, D, E again, and then also drop the altitude from C to L1 as F. The shape we have actually for both the angle BAC as 90 degrees or greater than 90 degrees are the same. How about let's combine the cases of 90 degrees and greater than 90 degrees together and see what we can find in this case. So let's continue with the pattern we have from our acute case. BC is still square root of 10x, because BC is equal to n20 times square root of 10. And our BD, let's say since each of the lines are still x distance apart, which is n20, so we can have these two still as x. And what we have next is DC is still going to be equal to 3x. And now in this case, instead of letting CF equals to y, let's let AE equals to y. So what that means is our AF is going to be equal to 3x minus y. 3x minus y. And our CF should still be 2x. And another thing we have is we still have our condition AC equals to AB. So these two lines are still equal to each other, or line segment. All right, so now let's set up our equation in this case by the Pythagorean theorem. What we have is x squared plus y squared is equal to 3x minus y squared plus 2x squared. All right, so what we have on the left-hand side is still x squared plus y squared, and if we simplify the right-hand side, what we have is 9x squared plus y squared minus 6xy plus 4x squared. So what we have is on the right-hand side, we have 13x squared, and then minus that x squared, we get 12x squared, and then we can still cancel out the y squared on both ends. And if we move the 6xy to the left-hand side, then we will have the equality as 6xy equals to 12x squared. And if we divide 6x on both ends, since we know that x is not equal to 0, then we're going to have y equals to 2x. This is very helpful, and I think let's try to maybe plug in this y equals to 2x into our diagram here. So if our y is equal to 2x, then 3x minus y will be equal to 3x minus 2x. So this will give us x. All right. And an interesting thing here now is we have BE equals to x, AF equals to x. Angle BEA as 90 degrees and angle AFC also as 90 degrees. And we will also have AE equals to FC as 2x. So what we can find here is that the edge of triangle BEA and triangle AFC are congruent triangles by SAS. And now what we can see, or what we can derive from this information, is that angle BEA will be equal to angle FAC. And we will also have angle EAB equal to angle FCA. What we also know is that the circle plus the x is equal to 90 degrees, so that this x plus this circle should also be equal to 90 degrees. What that means is these two angles adds up to 90 degrees. However, this entire angle gives us 180 degrees. And what that tells us is that this angle BAC is a right angle. Let's make it as clear a little bit. Okay, so this is a right angle. All right, what is this problem asking? This problem is asking us to find AC. So AC is this line segment. By Pythagorean theorem, what we can get is AC squared is going to be equal to AF squared plus FC squared. AF squared is x squared, and FC squared is 2x squared, which is 4x squared. And then this will be equal to AC squared. So x squared plus 4x squared is equal to 5x squared. This gives us that AC is equal to square root of 5 times x. And we also know that x is n20. So what that will help us is we know that AC is equal to n19 is equal to square root of 5x, which is equal to square root of 5 n20, because x is equal to n20. So now we finally set out an equation between n19 and n20. Let's write it down, maybe on the problem 20 side, since that will be useful information. So what we have is n19 is equal to square root of 5 and 20. Cool. And we also know that n19 is a positive number, which means that n20 will also be a positive number. Let's try to look at these three expressions one more time. Well, the first expression, we have n19 plus n20. Both of them are positive, which means that this expression will be greater than 0. If we look at the second expression, what this is equal to now is 2n20 minus n20. n19, remember, is equal to square root of 5 and 20. And 2 is basically square root of 4. And if we have square root of 4 minus square root of 5 and 20, this part is smaller than 0, which means that this expression is smaller than 0. How about the last expression? The last expression, we have a positive number times a positive number. That will also be greater than 0. So what we see is that among the three expressions, only 2 of them are greater than 0. And the problem statement tells us that exactly 2 of the following 3 expressions are equal. So what that means is our first expression is going to be equal to our third expression. Now, let's write it down. So n19 plus n20. We have n20 plus n19 is equal to square root of 5 and 20. That's going to be equal to this expression, which is square root of 5 and 20 times n20. Cool. If we take out the common factor of n20 here, we would have n20 times 1 plus square root of 5. And then on the right-hand side, what we have is square root of 5 times n20 times n20 again. So both ends has n20, and we also know that n20 is greater than 0, so that we can basically cancel out the n20 on both sides. And what we can do next is we can solve n20 here as 1 plus square root of 5 divided by square root of 5. And if we rationalize our denominator here, we will have 5, and then the numerator will be square root of 5 plus 5. And then this is also equal to 1 plus square root of 5 over 5. Finally, we solved our n20 as 1 plus square root of 5 over 5. And then we can use our expression of relationship between n19 and n20 here to get our n19. So that our n19 will be square root of 5 times 1 plus square root of 5 over 5. What this is square root of 5 plus square root of 5 times square root of 5 is 5, and then over 5, which is equal to square root of 5 plus 1. Ta-da! We got our answer for question 19 and also the answer to question 20. So this is basically everything for this set. I hope you find it very fun to solve, and see you in the next video.